Welcome to Math World. In our mathematical study, we have been studying real numbers, which includes 0, 1, 2, like that. It even includes decimals, say 2 repeating, 0.2 repeating, and it even includes, say, pi, e, etc., which we are quite familiar with this, right? Then we explored to something new that is quite interesting number, that is I, which is nothing but root of minus 1. That means a number, on squaring it, I'm getting a negative number, right? That's I. I is nothing but root of minus 1. This allows us to define a new class of numbers which are nothing but imaginary numbers. Imaginary numbers, say I, minus I, pi into I, e into I, like that. Okay. Now, this new class allows us to think what happens if I combine a real number with imaginary number, right? A combination of this is nothing but a complex number. That is what we are going to study, that is complex number. A complex number is a number that can be expressed in the form x plus iy, where x and y are the real numbers and I is a imaginary unit which satisfies the equation I square equal to minus 1. Got the point? Complex number is a number that can be expressed in the form x plus iy, where x and y are the real numbers and I is an imaginary unit which satisfies the equation I square equal to minus 1. When we write a complex number, we usually denote it by z equal to x plus iy. We write it like this, and x is nothing but the real part of z, of a complex number z, and this y is the imaginary part of z, and I is nothing but root of minus 1. So if I take set of all such numbers of this form, like 1 plus I, 1 minus I, like that, okay, these are all the complex numbers, and this set of complex numbers is usually denoted with a letter capital C. This complex number can also be defined as an ordered pairs x comma y, okay, of real numbers, which is interpreted as a points in the complex plane. Like, see, suppose if I have z equal to x plus iy, this is written in the normal form of a complex number, okay. If I write z equal to x comma y, now this is written in ordered pair, in terms of ordered pairs, and it denotes a point in the complex plane. What do you mean by complex plane? This is the complex plane. Here we call this x-axis as real axis and y-axis as imaginary axis. Okay, and the point x comma y is somewhere here. X is nothing but the value of real part of a complex number, that is along x-axis, and y is imaginary part of a complex number, and that is denoted along y-axis. So with the rectangular coordinates x and y, we are mentioning this complex number x plus iy over here, the point z. This is the point z. So any point on the real axis has got the value x comma 0, and any point on imaginary axis has got value 0 comma y. In fact, from this you can observe that set of complex numbers includes set of real numbers as a subset, right? So when we denote it like this, suppose z is a complex number x plus iy, which can also be written in this form in terms of ordered pairs, then this is a point z. This is the point z. Any point, if you take it over here, it's x comma 0, and if you take this one, say this is point I. I'll tell you what is I. In fact, I can be written as 0 plus I into 1, right? So real part value is 0 and imaginary part is 1. So this is I, which is nothing but the point 0 comma 1. Hope it is clear. Now let us go for some basic algebraic operations on complex numbers. Suppose you have two complex numbers, say z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2. Okay, now I'm writing it in complex form only. Okay, and here x1, x2, y1, y2 are the real numbers. Belongs to real numbers set. Okay, now what is addition of z1 plus z2? I'm adding two complex numbers, z1 plus z2, right? x1 plus iy1 plus x2 plus iy2. Here what you have to do is just have to add the real parts together and imaginary parts together. First add the real parts, so that this will be x1 plus x2 plus, keep I outside, so y1 plus y2. Okay, so this is if I have written z1 and z2 in terms of complex form only. Suppose if I have written z1 as an ordered pair x1 y1 and z2 as an ordered pair x2 y2, then z1 plus z2 will be, you can observe here, just mention the real parts along with the comma, real parts and the imaginary parts. This will be x1 plus x2, comma, y1 plus y2. This is addition. Similar to this, we can do subtraction. Suppose you want to find z1 minus z2, then just take x1 I y1 minus x2 I y2. Just take the real parts, x1 minus x2 plus I into y1 minus y2. So you can even write it in terms of ordered pairs. It's x1 minus x2, comma, y1 minus y2. Okay. So main thing is, when it comes to multiplication, you are multiplying two complex numbers, x1 plus iy1 into x2 plus iy2. Now here multiply all the terms together, like x1 with x2, then x1 with I, y2, like that you have to do. x1, x2, this one with this, plus x1 with this, x1 I, y2, plus this term with these two, I, y1, x2, plus I, y1 into I, y2. Okay, now keep this as it is, x1, x2, plus I write I, will take out I from these two, so that this will be x1, y2 plus y1, x2 plus I square y1, y2. I know I square is nothing but minus 1, so that I'm taking these two terms together, so that this will be x1 into x2 minus 1 y1 y2, because I square is minus 1. So minus 1 y1 y2, instead of writing 1, I'll directly write y1 y2. This is the real part, I x1 y2 plus y1 x2, which is a imaginary part. So I got this z1 z2 is x1 x2 minus y1 y2 comma x1 y2 plus y1 x2, if you want to write it in the form of an ordered pair, x1 x2 minus y1 y2 comma x1 y2 plus y1 x2. Okay, this is z1 z2. And suppose you want to divide the complex numbers, z1 by z2, x1 plus I y1 divided by x2 plus I y2, then we do conjugate multiplication. Okay, this is same as writing, in fact z1 by z2 is same as writing z1 into z2 bar or z2 inverse, that I'll mention while solving the problem. Okay, what we have to do is we just have to take a conjugate of this. Conjugate means this is plus, no, when you take a conjugate that will be negative, x2 minus I y2 divided by x2 minus I y2, then go for the multiplication. Okay, I'll explain you these operations, basic operations, using an example. Say z1 is equal to 1 plus I and z2 equal to 3 minus I. Okay, first thing I'll tell you how to calculate z1 plus z2, addition of two complex numbers. z1 is 1 plus I, z1 plus z2, z2 is 3 minus I. What you have to do is you have to take up real parts and imaginary parts separately. So first real part, sum of the real parts, 3 plus 1 is 4, then plus I minus I will get cancelled, so z1 plus z2 is 4. In fact, it is purely real because the imaginary part in this is 0, right? So we say z1 plus z2 is purely real. Okay, then z1 minus z2 is 1 plus I minus 3 minus I. So 1 plus I minus 3, minus into minus plus, so plus I. 1 minus 3 is minus 2, plus I is 2I. Okay, this is the real part and this is the imaginary part. You can even write it like this. Okay, fine. Then z1 into z2, 1 plus I into 3 minus I. 1 into 3, just like, see, do the multiplication just like how we do a plus b into a minus b or a plus b square, like that. Okay, when you have two terms algebraic expression, how do you multiply? In the same manner here also we have to do. Okay, 1 plus 1 into 3 is 3, 1 into minus I is minus I, then I into 3 is 3I, then I into minus I is minus I square. We know I square equal to minus 1. Therefore 3 minus I plus 3I is plus 2I, and I square is minus 1. Okay, so 3 plus 1 is 4 plus 2I. This is Z1 into Z2. Then Z1 by Z2. Z1 is, need not be Z1 by Z2, it may be as Z2 by Z1. Okay, it's your wish. Let me take Z2 by Z1. 3 minus I by 1 plus I. Okay, I'm taking Z2 by Z1. What I have to do is, I have to multiply and divide by the conjugate of the denominator. Okay, here the denominator is 1 plus I. Conjugate means 1 minus I. So 1 minus I divided by 1 minus I. Now do actual multiplication, numerator with the numerator and denominator with the denominator, so that you are getting 3 into 1 is 3, 3 into minus I is minus 3I, minus I plus I square divided by, this is a plus b into a minus b, so it's a square minus b square. So 3 minus 3I minus I is minus 4I, then I square is minus 1. 1 minus of minus 1. So that 3 minus 1 is 4 minus 4I divided by, minus of minus is plus, so 1 plus 1 it is 2. In fact, it's same as writing 4 by 2 minus 4 by 2I, which is same as writing, which is same as writing 2 minus 2I. This is Z2 by Z1. Similarly, you can try by taking Z1 by Z2, or you can do operations like Z1 into Z2 by Z1. Okay, you can even calculate Z2 into Z1 plus Z2 like this. Okay, I'll explain few more operations in my next class. Thank you.